All right, so picture this. The actual brain of your entire AI operation being turned against you. That's the hidden battlefield we're talking about today. This isn't about hacking servers anymore. It's about hijacking the very intelligence, the very decision-making power that you've worked so hard to build. Today we're going to dive deep and figure out how to secure these AI models from the inside out.
And just before we jump in, a quick heads up, everything we're covering in this explainer comes directly from Chapter 5 of the tutorial provided by Virtualization Options LLC.
So think of this as our intelligence briefing for the day. First, we're going to get a handle on this new kind of threat. Then we'll perform an autopsy, really dissect the anatomy of an AI attack. After that, it's all about defense, fortifying your models, looking at active defense strategies, and we'll wrap up with the absolutely critical but often forgotten part of securing your supply chain. Let's get to it. So, you might be wondering, what's the big deal? Why is this so different from traditional cybersecurity? Well, think of regular software like a cookbook. It follows a precise set of instructions and that's it. But an AI model, that's more like a chef. It learns, it improvises, it makes its own decisions. And that very quality means it can be tricked, manipulated, and fooled in ways that old-school security it can't even see it coming.
And this quote right here, it just perfectly captures the stakes. We're not just talking about a system crashing. A compromised AI can actively, intelligently work against you. It could start making terrible business decisions, leaking your most sensitive data, or worse, become a silent tool for an attacker, all while looking like it's doing its job perfectly. That's the scary part.
Okay, so if we want to build a rock-solid defense, we have to know what we're up against. You gotta know your enemy. So let's break down the 4 main ways an attacker can come after your AI model.
First up, we have what are called adversarial attacks. The best way to think about these is like optical illusions, but for machine. An attacker makes a tiny, often humanly imperceptible change to a piece of data, and boom, suddenly your AI is completely fooled. Your self-driving cars model might see a stop sign and classify it as a green light. You can imagine how catastrophic the consequences can be.
Next on the list is model extraction. And let's be blunt, this is high-tech corporate espionage, plain and simple. By cleverly pinging your model with inputs and just watching the outputs, an attacker can literally reverse engineer your entire model. All that time, all that money, all that competitive advantage you built, stolen.
Then we've got something incredibly sneaky, backdoor injection. This is like planting a deep cover sleeper agent inside your AI during its training phase. The model acts perfectly normal for months, maybe even years. But then, the attacker presents a secret trigger, a specific image, a keyword, a sound, and that sleeper agent wakes up and causes the model to do something malicious.
And finally, there's model poisoning. This one is all about corrupting the AI's education from the start. If an attacker can secretly feed bad data into your training set, they can either subtly degrade the model's overall performance or, even more sinister, build in specific vulnerabilities that only they know how to exploit later on.
Okay, these threats are not science fiction. They're real, they're sophisticated, and they're frankly a bit terrifying. So the big question is, how do we fight back? How do you possibly defend against an enemy that can poison your AI's mind or trick its eyes?
Well, you fight back by building layers. It all starts with the first line of defense, fortifying the model itself. This is all about making that core asset, your model, as solid and as tamper-proof as possible right from the get-go.
And the strategy here is really a fascinating two-pronged approach. On one side, you have cryptographic protection. Think of this as locking your model in a digital vault. You use digital signatures and hashes to prove, without a doubt, that it hasn't been tampered with. But on the other side, you have behavioral monitoring. This is like having a security guard watching the model 24/7, looking for any strange decisions, any deviations from the norm that might signal a compromise. And this is a super important point to grasp. Security is not a one-and-done checkbox. It's a continuous life cycle. It starts before you even deploy, with validation and testing. It continues at deployment with secure packaging. It's constant during runtime with that behavioral monitoring we just talked about. And it even applies to every single update. It never, ever stops.
But just building strong walls isn't enough for the most determined attackers. That's why we need to move beyond static defenses and into active countermeasures. These are the strategies you use to teach your model how to actually fight back.
The biggest weapon in this fight is something called adversarial training. Honestly, it's like a vaccination program for your AI. You intentionally create those optical illusions we talked about earlier, those tricky inputs, and you show them to the model during training. You expose it to the attack in a safe environment, so it learns to recognize the patterns and becomes immune, or at least highly resistant to them in the real world.
And of course, we've got other tools in the arsenal. There's input sanitation, which is basically a bouncer at the club door, checking every piece of data before it's allowed anywhere near your AI. Then you have ensemble methods. This is the safety in numbers play. Instead of relying on one model, use a whole team of them, and a decision is only valid if they all agree. It's much, much harder to fool the entire team than it is to fool a single player.
But here's the kicker. You can do all of this, have a perfectly fortified, actively defended model, and it can all be for nothing if it's built on a shaky foundation. This brings us to our last and maybe the most overlooked piece of the puzzle, the AI supply chain.
I mean, just think about it. If you were building a house, you wouldn't use concrete from some random unmarked truck, would you? Of course not. The same exact logic applies to AI. Are you using a pre-trained model you downloaded? A data set from a third party? Every single one of those components is a potential entry point for an attack. You have to verify your sources, scan everything for vulnerabilities, and have a formal sign-off process for every single piece you use.
So when you boil it all down, it really comes to this. The technology is amazing, but technology alone will not save you. You absolutely need those automated technical controls we've discussed, the crypto, the monitoring, the sanitization. But they have to be paired with rigorous processes and smart, dedicated human oversight. It's a true partnership between the machine and the people protecting it.
So I'll just leave you with this one question to really think about. Right now, your AI is making critical, high-stakes decisions for your business. After everything we've just covered, can you say with 100% certainty that those decisions are truly its own?